All right. Hey, APE Scholars. Welcome to the 2025 exam live stream review session. We're going to be doing units 1 through 5 today, and we're going to try and get into it quick without too much preamble, without too much yapping by me, because you guys have an exam on Tuesday. You need to review, and that's why you're here. All right. Couple housekeeping things before we get too far into unit review or content review here. We have two moderators here tonight, Kyra and Reed. They're both former APE scholars, so they're both able to try to answer some content questions. They can both also hopefully direct you in the right direction of different links you may need. There's a pinned comment, which is the link tree. So anytime you have a question about a link, that's the best place to check. So you want to go to the link tree, check out that link. The video description for this live stream, so if you go, down here in that direction, you're going to find a whole bunch of links that I talk about in this live stream. If you want the slides that are on the screen, right here, no, right over there, those are right in the video description below. Unit 9 slides are in the video description. Unit 5 slides are in the unit video description. Math reviews down there. So the most important stuff that you should be focusing on these last few nights is going to be down in that video description. So check those two places. The other thing is the chat is going to go too fast for me to answer most of your questions like in live time. I'm going to focus on helping you review. That's the goal here. I know it's fun to come together as an APES community to ask questions, to joke, but we're going to try to keep it focused on the units that we want to review. I will stop and pause, especially at the breaks for units. So there'll be a break for each unit. I'll take a break for a second, rest my voice. You can hopefully have your question answered then. If we get really good questions that come up throughout, I might try to throw them up on the screen and go through them. But by and large, I'm going to try to focus on reviewing content and then save those shout outs and questions and all those things for in between unit breaks. All right, here we go. If you have watched any of the old live streams, you got to crack a LaCroix to get started. And if you're one of my students at Grand River, you know that I'm not ready to teach until I got a LaCroix open. So here we are, 2025 live stream review session underway. Okay, so what I want to do is start and talk to people who are panicking because they have barely started studying. The reality is a lot of those people are at the live stream tonight. They're here, they're worried. So if you're in this first camp, you're totally panicking, you're totally unprepared. There's a 2-day plan to try and pass the APES exam. I'm not going to pretend you can cover all the course content in 2 days. You can't. But you can cover the most important stuff, and you can practice a little bit of FRQ writing so you're more familiar with that. If you're totally unprepared, totally panicking, check out the 2-day study plan. It's in the free preview of the Ultimate Review Packet. So you don't have to buy the Ultimate Review Packet. Just go into it to get a free preview, and that 2-day plan is going to be right in there. If you're worried and you're kind of stressed, but you have been preparing for a while now and you've been engaged in class, you think there's a decent chance you're going to get the score you want. You kind of know if you're in that middle category. This is where I'd really look at experimental design and math skills. Those are both linked in this slideshow. We're on slide 2. And then I'd also look at your lowest units or potentially look at units 9 and 5, and I'll talk about why in a second. And then finally, if you're not too worried and you're pretty well prepared, first of all, thank you, past self. You've done a lot to think like a mountain and write like a scholar this year, so way to go. Way to be in a good position right now. Also, thank your teacher. Your teachers have worked hard to get you to this point. Thank your teachers anyway, no matter where you are in these 3 camps. But especially if you're feeling really prepared, say, wow, Miss Johnson or Mr. Smith, they did a great job. And thank them. And then you could just do some practice FRQs, maybe look at FRQs from last year. I would brush up on recent FRQs if I was in this like totally prepared, not really worried camp. All right. So like I said, I'll try to answer questions as we go. I'm going to aim though for answering questions at breaks. If a question comes up and it seems relevant to the unit we're talking about currently, I might put it up on the screen and try to answer it so that it's helpful. But remember also, if you get the Ultimate Review Packet, you already have that. I'm going to do an exclusive live review just for those students from 9:30 to 10, and that's going to be basically purely Q&A. So like that's an avenue where you can ask question after question, get a response from me, walk through a diagram, I'll pull up whatever slides or videos are relevant, and we'll go right through it. So that'll be much more Q&A. And there's 2 different sessions of those. There's the one tonight and the one tomorrow night. So that'll be much more focused on just answering your questions. All right. Like I said about the shout outs, we'll try to do some teacher shout outs at the breaks, but we will try to save those for breaks so that we can stay focused here. Okay. So here's my last minute advice. This is to the first group of people who are panicking. Unit 9 is 15 to 20% of the exam, and it has a ton of environmental solutions, which from a skill standpoint are a huge part of the exam. I'm going to actually tweak our view a little bit here so you can see the slides better. So we can see environmental solutions are 17 to 23% of the multiple choice portion, and they're 26 to 34% of the FRQ portion from a skill standpoint. Meaning, if you study Unit 9, you're not only reviewing the content, Unit 9, but you're also reviewing the types of questions, propose a solution, and to an environmental problem that you're likely to see on both sections of the exam. So I can't recommend Unit 9 highly enough. Unit 5 also 10 to 15% of the exam. And Unit 5 has come up on every FRQ from 2021 to 2024. And so Unit 5 is like almost sure to be on the FRQ. People always ask, what are your FRQ predictions? Last year, I kind of threw in the towel and said, all I'm going to do is just say Unit 5 is going to be on the FRQ for sure. Because every year in the past, I've been 0 for 3. I always get the predictions wrong. You can't really predict. It's not like they have a big board where they're like, this year's 1.1, next year's 1.2. It's not like they're crossing topics off as they go. Unit 5 keeps coming up because it's about land use, and that lends itself to experiments really well. It lends itself to environmental problems and solutions really well, and it lends itself to math really well. And guess what? Those are the 3 FRQs. Experiment and propose a solution to environmental problem, and then math. And so they just keep showing up time and time again. So study Units 9, study Unit 5, and then finally the math review. I just want to tell a very brief story. On Thursday, I had an APES scholar who all year she's been scoring right in the 3 range, but sometimes just a teeny bit below. So I predicted her exam score the other day using all those data. I said, you're probably going to score a 3, but lately your third FRQ, your math FRQ has been really weak. I'm a little worried you might score a 2. She took a practice test in class on Thursday, and she scored 1 out of 10 on the math FRQ. She had a 5 on FRQ number 1, a 6 on FRQ number 1, on 2, which is perfectly on track for a 3, maybe even a 4. She got a 1 out of 10 on FRQ number 3. She took the Math Ultimate Review packet, and she did the unit conversion page, just 1 page, 4 practice problems. Took her 25 minutes. I gave her another full-length practice FRQ, number 3 with the math on it. She took that. She got 8 out of 10. She got all 6 math points with flawless setup, units everywhere. And I was like, what happened? It's like you couldn't do math 4 hours ago, and now you can do all the math with no problem. And she's like, oh, I just didn't know how to do it. I hadn't done the review packet. So I bring it up for 2 reasons. One, the math that you have to do on FRQ number 3, you can learn it in a very short amount of time. You can totally learn it in a short amount of time. You also know the math is 11 to 13% of the exam. It's 6 out of the 30 FRQ points, and it's going to be like 6 to 9% of the points on the MCQ section. And so you add that together, and that's like 11 to 13% of the exam. So you're going to see math, and it's predictable math. So again, I highly recommend watching the math review video. It's linked in the video description down. I got to get used to pointing on the opposite side, down below in the video description. And it's also right on my YouTube channel. If you just search APES Math Review, it'll pop right up. So that is a really good return on investment of the time that you might spend tonight or tomorrow on it. So these are my big 3 tips for anybody who's underprepared. Okay. Let's keep going here. Like I said, tonight we're going to focus on units 1 through 5. And in each unit, what I tried to do is pull out the most confusing concepts. So the concepts that are the most complex. Some concepts, they're really easy. You can understand them on your own. Some of them, students make common mistakes on the exam. And since I grade the exams every year, I grade the FRQ section, I see these common mistakes that come up year after year. The second thing I'm going to do with every unit is give you some what I'm going to call must-know vocab terms. These are terms that just keep showing up on FRQs and MCQs over and over and over again. They're very likely to show up on your exam, either on the MCQ or the FRQ. What I added to this year's stream that's different from previous years, and I hope this is helpful, is predicting. I know I said I wasn't going to predict FRQ topics, but I guess what I did is for each unit, I put on the side of the screen, which you'll see in a second, the most likely FRQ topics from that unit. So if there's going to be an FRQ about unit 1, here are the 3 topics I think are most likely to be on that FRQ, and I'll explain why when I go through those. And so that's kind of what today's live stream is going to look like for units 1 through 5. Tomorrow's live stream will be units 6 through 9, and we'll do a little bit more touching on math concepts and an FRQ walkthrough in that review because we have less content to get through. It's only 4 units to get through instead of 5. So that's what tomorrow's live stream review will look like. Okay, let's take a look here at our next unit, which is unit 1, or our first unit, ecosystems. We also have, let's see here, some tickers so we can kind of make sure we know where we are. So we're at unit 1, 6 to 8% of the exam. And the reason I like that is it just gives us some context. So we're not going to spend a huge amount of time on unit 1 because it's 6 to 8% of the exam, but we're going to go through as well as we can here. Okay, so the carbon cycle. The carbon cycle is a complicated topic. It's not a super straightforward thing. We don't see carbon every day when we're walking around, at least we don't realize we do. So let's go through some of the complicated steps of the carbon cycle. The one that I think is the least understood or the least articulated well on the exam is direct exchange. So in direct exchange, carbon is moving between the atmosphere and the ocean in either direction. The verb you'd want to use on an FRQ is that carbon dioxide is dissolving into the ocean water, or you could just say leaving the ocean via direct exchange. And so that's important because the ocean is a giant carbon sink, right? Something that can take carbon in out of the atmosphere. It's also a carbon source, though, because it can give carbon off. And because of this direct exchange, when we increase atmospheric CO2 concentrations, we also increase CO2 concentrations in the ocean. And that's why we get ocean acidification. So we'll talk about that tomorrow with Unit 9, but increasing CO2 in the atmosphere also acidifies the ocean. And this is important, though, from the carbon cycle, because when we put more carbon in the atmosphere, the ocean can take it out via the biosphere. So we could have algae or zooplankton that are taking that in. We could have calcium carbonate shell-building organisms like coral and mollusks that are going to use that carbon dioxide that comes from the atmosphere, dissolves into the water, and then they take it out of the water to combine it with calcium to make a calcium carbonate shell. So that's an important kind of biosphere, or living sink of carbon in the ocean. And then, of course, when those things die, they sink to the bottom of the ocean, and sedimentation is this act of their little dead sediments or bodies that kind of get compressed by all that ocean mass above them and cemented into limestone or sedimentary rock. And so now that's buried carbon at the bottom of the ocean. And so that's carbon that's not in the atmosphere. It's now in kind of a geological carbon reservoir. So the other thing you want to think about here is short versus fast processes. So the respiration photosynthesis cycling of carbon is very fast. That carbon leaves the atmosphere and goes back into the biosphere very quickly, and then it leaves the biosphere and goes back to the atmosphere pretty quickly. So that's a quick carbon cycle. It's not really changing net carbon levels in the atmosphere a ton. The reason that digging up fossil fuels and burning them changes atmospheric carbon levels so much is that carbon was sequestered or stored for a long period of time, what we would sometimes say a geologic period of time. Then we burn the carbon, and the carbon dioxide goes in the atmosphere very fast. And so that's going to shift global temperature because that carbon is being added to the atmosphere way faster than it comes out of the atmosphere via that whole burial process and then the compression into forming fossil fuels. They take millions of years to form, hundreds of millions of years to form, and then they take, you starting your car engine to burn and go back into the atmosphere. This is a very short process. So these are some of the major carbon cycle concepts that you want to be familiar with. Okay, nitrogen fixation. Nitrogen is another important concept because nitrogen is such an important nutrient, right? Plants need nitrogen to grow. It's often what we would call the limiting nutrient in either an aquatic or terrestrial ecosystem, but especially an aquatic ecosystem. And so we need nitrogen in order to live. We need it for our DNA, we need it for proteins, for all sorts of things. So the problem with nitrogen is in the atmosphere, there's tons of it. The atmosphere is the major nitrogen reservoir. So there's a whole bunch of it there, but it exists as N2 gas. So these are two nitrogen molecules triple bonded together. That triple bond is extremely strong. And so plants or humans, we can't break that triple bond naturally with our body the way we can break a lot of chemical bonds with our body. And so we rely on fixation of nitrogen by bacteria that are evolved to have these really specialized enzymes that can break apart that nitrogen and then pair it with hydrogen. So if we look at our diagram here, we can have what's called biological nitrogen fixation by bacteria that either live freely in the soil, but oftentimes they're bacteria that have this symbiotic relationship, mutualistic relationship to be specific, where they live in the root nodules of certain plants like legumes. So, think like peas and types of beans. They're going to house the bacteria. We call these rhizobacteria, rhizo for root. And they live in the bacteria and they fix nitrogen through this nitrogen fixation, this enzyme that they have that can break apart the N2 double bond and pair it with hydrogen to make ammonia. And then the plant gets nitrogen, which is a great deal for the plant. And sugars from the plant flow down to the bacteria that live in those root nodules, and they get sugar, which is a huge energy source. So it's almost like having your own live-in chef that lives in your house, and you pay the chef money, and the chef makes you food. And then you don't have to go out and get your own food, or at least all of your own food, since the nitrogen, a main nutrient, is right there in your root system. So this is a super beneficial relationship. And the reason we have just this focus on nitrogen fixation is it's such a key step in the process. Now, we can synthetically fix nitrogen by burning fossil fuels. So we can make fertilizers that, again, are synthetically fixed. And that creates a whole bunch of fertilizer we can use, but it uses fossil fuels. So that's a big drawback of using those fertilizers. And then we don't have it on this slide, but of course, over-application of fertilizers can lead to eutrophication. And eutrophication is one of the most misunderstood and misused terms on APES exams. And so we'll go over it tomorrow in depth because it comes up in Unit 8. All right. Do always like to try to check the chat just to make sure I'm not missing any important questions. Let's just throw up something here which is important. Phosphorus is the slowest of all the cycles, which is true. The nitrogen cycle is quite fast compared to the phosphorus cycle due to the nitrogen cycle having this huge atmospheric component. Phosphorus doesn't enter the atmosphere in its phase on Earth, in its cycle on Earth. It just doesn't volatilize at temperatures that we normally get on Earth. So it cycles very slowly, usually by the weathering of rocks. We get geological uplift that bring the rocks up to the surface, and then weathering breaks down the rock into smaller components, and those phosphates come out and then get washed into soil and water by runoff. All right. That's a good comment here from Geo Tricky, and a fitting name. Look at that, Geo in the name. If that Geo Tricky stands for geology, you nailed it. The phosphorus cycle has a major geological component. So sometimes the name fits the comment. Okay, let's move on here. I see a few questions about all of the other nitrogen cycle steps. We're not going to touch on them. They're just not usually big FRQ topics. And fixation is just a major topic. If you're worried about the other ones, you can watch the 1.5 video. But again, let's look at that banner at the bottom of the screen. Unit 1 is 6 to 8% in the exam. There's 11 topics in Unit 1. The nitrogen cycle, we'd expect to make up 1% or less of the exam. And if you see it, we're thinking it's more likely to be fixation than anything else. So I always want to make sure people in the chat understand my rationale for not explaining a topic. It's not that the topic is super simple. I think you can get it easily. It's just that with such little time to go before the test, I really want to help you study what's most likely to be on the test. And so I see your comments about the nitrogen cycle, and it's just not the best use of our time. What's a really good use of our time is seeing if you guys can describe an advantage of crop rotation using legumes on soil fertility. Go ahead, type away. Let's drop it in the chat, and we'll see if we can get somebody who would have earned a point here. We'll put their answer up on screen, and we'll go over it together. Oh, all right. I think we got a winner. Aishi. I'm sorry if I mispronounce your name. Aishi. Aishi. You could do a phonetic spelling of it in the chat if you'd like. Crop rotation using legumes enriches soil with nitrogen through the process of nitrogen fixation. Good. Adding that as nitrogen fixation is a very important vocab term. The legumes nitrogen fixing bacteria turn atmospheric nitrogen into ammonia. That's another nice point to add in, which can be used by plants. The only component that might be missing here, Aishi, is describing this taking place in the soil. That can sometimes be important, but let's go to the scoring guide and let's see how this might be scored. Improve nitrogen fixation in the soil. Less nitrogen-based fertilizers are required. I think you're probably going to get this point if this was your answer on the exam, because the fact that you're saying the legumes nitrogen-fixing bacteria, you're really kind of pointing your reader to saying, hey, I know that these fixing bacteria are in the root nodules in the soil. So even though you didn't say improve nitrogen fixation in the soil, you've said it's nitrogen fixation. You've clearly stated it's into ammonia, which can be used by plants. So a lot of your evidence is aiming at that you understand it's in the soil. The other reason I like to talk through these is to help you understand that your reader, they're not really allowed to like make assumptions about what you know, but they can take all of your wording and they can sort of see where its logical conclusion heads. And so this is kind of the process that someone who would grade your exam would go through. And again, this is going to be my 6th year grading exams. We're going to be in Cleveland this year. So some of your teachers may even be in Cleveland in a little bit grading exams with me. And a bunch of other teachers. There's probably 200 of us there. And it's really a lot of fun. So that's where I kind of try to draw my FRQ grading experience from as I give feedback here. So nice job. One more quick answer. Again, a fitting YouTube name for your comment. I Love Food says a legume is a plant that belongs in the pea family. And that's a good example. Beans, often many types of beans will be considered legumes as well. So a lot of people were asking what a legume was. So this is good. I Love Food. I would recommend hummus if you like food and you like legumes. It's a great legume-based food made with garbanzo beans. I love hummus. I make a lot of homemade hummus. Would definitely recommend hummus. Definite, very tasty snack. All right, the trophic pyramid. This is a big one. 10% rule. So remember that at the base of the trophic pyramid, we're looking down at the grass there at the producer level. We have kind of 100% of the energy. Now that's a tiny bit misleading, because if we were really saying how much of the sun's energy do they capture, they don't capture 100% of the sun's energy. So I just want to make that clear. But we can say that all of the energy in the producer level is what we would consider 100% of the biomass energy in any biome. So, you know, the rabbits, they're not going to go to Walmart and buy Takis or go to Taco Bell or whatever. Like, the only energy available to them in a natural ecosystem is everything at the producer level, right? And so we're representing that with 100%. So what happens is those rabbits eat the grass. They jump around, they run away from foxes, they reproduce, they grow, they go through a whole bunch of metabolic processes. So 90% of their energy is given off as heat through their movement and through their metabolism and through all the processes their body does to be a rabbit. The way I think of it is it's like taxes. Like, the tax to be a rabbit is energetically, you've got to use about 90% of your energy to just be a rabbit. Some of that as well is represented in what we call indigestible biomass. So the snake eats the rabbit, and some of the rabbit's parts come out in the snake's, waste, and the snake's not able to use every little bit of energy from the rabbit. And that combination of respiration loss or heat loss and then indigestible biomass means only 90% of the energy moves on to the next, or only 10% of the energy moves on to the next level. So the reason this is so important is it comes up on FRQs. Right? So we might say, why can there only be a few eagles in a huge forest or in a really large forest or something? And the answer is, if the eagles are eating snakes and the snakes are eating rabbits and the rabbits are eating producers, we need, 10 times, 100 times, 1,000 times. We need 1,000 times as much plant biomass, like per unit of tertiary consumer food, right? So when they eat the snake, they get 1% of the original 100%. When the snake eats the rabbit, the snake gets 10% of that original energy. And when the rabbit eats the biomass at the bottom, they get 10% of that 100%. And so that just means that you need a huge amount of land, because the amount of energy that can transfer from the land to the rabbit shrinks down to only 10%. The amount of energy from the rabbit to the snakes shrinks down to only 10%. And then by the time we're at the top with the tertiary consumer, that energy shrinks down to 10% again. So it's 0.1% of the original space, or the original amount of energy. And biomass, space, and energy have a kind of, it's not a linear relationship, but it's proportional, right? To have 1,000 times as much plant energy as eagle energy, you need a big amount of space. So there's your answer for kind of why this can be such an important concept. Okay, let's throw a question up on the screen, because I think this is a valuable question. Why is there 90% loss? So, I don't know if this person wanted their whole first, last name, and face on the screen, but oops, oh well. 90% loss. Why is there 90% loss? So again, the rabbit has to jump around and like be a rabbit, and that takes a lot of energy. Even right now, you guys probably can't tell, but talking, like holding my posture upright, thinking, all that takes energy. So I'm a little bit warm. It's what, 70 something here in Michigan. And so even just now I'm using some energy. So I ate earlier today. I actually had my bowl of, I had peanut butter puffins and some blueberries. That was my dinner because I was putting the slides together. So if a lion came in here, and ate me, he's not going to get all, that lion's not going to get all of my, cereal energy that I ate, because I'm using up some of the energy right now. Energy is leaving my body as heat because of my cellular respiration and because of my movement and everything. And so that energy just doesn't make it to the lion. And then the lion probably wouldn't be able to eat every single part of me. And so some of that energy would stay in the part of me the lion couldn't eat. So I got kind of morbid there real quick. But yeah, you get the idea. Gotta love a Michigan shout out. Oh, beautiful. Beautiful, like what looks almost like Delftware on the mugs there from Michigan. You love to see it. So Night Meadow's also from Michigan. Yeah, and another peanut butter enjoyer. Yeah, you guys have crazy YouTube names. What? Oh man. I just get a kick out of how almost nobody's YouTube name is their real name. It's like something weird. All right, I think we got to get your sister's eating pad off the screen. Okay. I suppose it is time for some teacher shout outs. Miss Carsos. Miss Carsos, if you're here, if you see the replay, your students appreciate you. You've got some Harry Potter fans and some scholars. So good work. Shout out to Mr. Hunt as well. Your students appreciate you. It sounds like you've got them well prepared. You can't do every single one of these, but let's do one more. When you get a specific one, I guess that's kind of fun. Miss Damos, excuse me. Your students want to give you a nice shout out. Oh boy, now they're really flying in. Okay, we'll do one more before we go on to talk about, oh, there we go, to Mrs. Redmond. So your scholars appreciate you as well, Mrs. Redmond, it sounds like. Okay, what I want to do is not just teacher shout outs. It is great to appreciate teachers. That's actually one of my favorite things about this night where we all get together and review is seeing how much you guys appreciate your teachers and how much you are thankful for the work they do. It takes a lot of work. It's really hard. So this channel is a place I always want to applaud fellow teachers' efforts. Anyway, these are what I would consider Unit 1 must-know vocab terms. They're likely to come up on exam, either on the MCQ or the FRQ. I would especially star like the trophic level and the 10% rule and carbon sequestration. Carbon sequestration just has a very high likelihood that either you're asked explicitly about it or you're able to use it on an FRQ. So carbon sequestration is the act of storing carbon. It's a fancy word for store. So an old growth forest is a great way to sequester carbon. The trees take the carbon in, they store it in their bark and their leaves and their roots for a long period of time, and it isn't in the atmosphere then. Carbon sequestration also happens in the ocean. Remember, CO2 dissolves into the ocean from the atmosphere, gets taken up by organisms in the ocean, they die, they sink to the bottom, and then they get buried. The pressure of the ocean kind of compresses them, they form sedimentary rocks, and there we have carbon sequestered there. So carbon sequestration is a really big term. Most likely FRQ topics. Actually, this is a good question. This is a good clarification here. Is carbon sequestration just a carbon sink? Carbon sinks do more carbon sequestration than releasing of carbon, is the way I would use those terms, Joyce. So great question. Yeah, anything that stores carbon and stores more than it gives off, because most things take in and give off carbon, but anything that stores more than it gives off, we would call that a carbon sink, and a carbon sink does the action of sequestering or storing carbon. Soil and wetlands can also sequester carbon. They can take carbon deep into the soil. When plants die and they fall into the soil and they get kind of decomposed down into the soil, some of that carbon gets returned. So it's another way that soils can sequester carbon. Same thing with wetlands. All right, one final question here. Oops, that's not what I meant to click on. So a tree is a carbon sink? Yes, definitely. But actually the one I meant to click on was here. What's the difference between a sink and a reservoir? Reservoir is kind of like a stop in the carbon cycle. So it's kind of a generic term for like something that can hold carbon, but a sink specifically takes in more carbon than it gives off. All right, it's a good question. Okay. So most likely FRQ topics, carbon cycle, it just comes up a lot. There's the combustion of fossil fuels, there's carbon sequestration. I would review 1.4 if you're nervous about Unit 1. Primary productivity, it has a likelihood of coming up on an FRQ. We're often talking about plants growing, their rate of growth, factors that affect their rate of growth. Primary productivity could very well come up. 10% rule as well, right? We went over kind of the why behind that. Okay, just for fun and just to give me some breaks in just yapping about apes, after each of the 5 units, I have a recommended FRQ topic, but then I have a recommended album. Sometimes when you're studying, it's nice to listen to music. I don't know that I'd listen to music with words when I study, but maybe you need a little break. Maybe you need hype up music. Women in Music Part 3, Heim, wonderful album. Highly recommend it. So if you're looking for something to listen to relax or on your way to school, check it out. Very, very good album. I've been listening to it a lot this spring. All right. Here we go. This was to remind me last year to take a drink of water so I don't go too long. Okay. Try to grab a couple more useful questions. Oh, that's not what I meant to show. I'm always missing the questions because they come in so quick in the chat. You can bring a calculator, but there'll be a built-in one on Blue Book. So if you forget a calculator, there'll be one right in the testing application for you. So I wouldn't worry about the Blue Book too much. All right, one more question. We got a strawberry peach LaCroix. Huge LaCroix fan, and so we got a strawberry peach. It's a really nice flavor. Okay, on we go. Unit 2, biodiversity. This topic, biodiversity, Unit 2 specifically, 2.1. Biggest, I'm the most confident that you're going to see biodiversity in your exam of almost any topic in the whole course. Global climate change, global warming, greenhouse gases. Yeah, that's no doubt, 1000%. Like you can bet on that. You'll see those concepts on the exam. Biodiversity is like second place. Almost guaranteed to see questions about biodiversity both on MCQ and FRQ. So let's review the 3 levels. You've got ecosystem, you've got species, you've got genetic, and they go from big to small. Ecosystem diversity is like within a large area, like a state or a country, do we have a whole lot of different ecosystems? Do we have, a swamp ecosystem? Do we have like a boreal forest ecosystem? Do we have kind of a meadow ecosystem? Do we have any alpine ecosystem going on? And so high ecosystem diversity is nice because it supports a bunch of species. Think about a large island versus a small island. A large island likely has greater ecosystem diversity. A small island likely has lower ecosystem diversity. Excuse me. Species diversity is also really important. With species diversity, we're talking about like the number of different species in an area. So sometimes we call it richness, like just the total number of species, but you also want to think about evenness, which is kind of how evenly distributed they are between all of those different species. So do you have one super dominant species? Or do you have really balanced number of individuals in each species? And so that's beneficial because now you have a complex food web with a lot of different organisms at each trophic level. So if our chipmunks decline, maybe we have rabbits that the birds of prey can eat. If there's a certain type of tree that suffers a disease or a certain type of bush that dies out, we have a likelihood that there's another type of bush or another type of tree that woodpeckers may still nest in, or that squirrels may still harvest the acorns of, or eat the leaves of, right? So the key, what I'm trying to focus on here with biodiversity is everybody knows what it is. And so they fall into the trap of familiarity. They think, oh, I know what biodiversity is. I don't need to study it. What you need to focus on is, why does biodiversity matter? Why is it beneficial to ecosystems? And so that's what I want you to take away from here. The ecosystem is more stable when it's more biodiverse. Okay, this is another example. I think a lot of students know genetic diversity is good, but why? If environmental disturbance hits, a genetically diverse population has a higher likelihood of, dealing with that environmental stressor, right? And so you might have some organisms some potatoes here, for example, that are resistant to blight. And we have some potatoes that are going to fall susceptible to blight, and they're going to die off, and they're not going to be able to survive. So if you have cloned potatoes or a GMO strain that's all exactly the same, and then you have super diverse potatoes that are all from different, genetic strains, slightly, they have different genes, you're going to have some that survive the blight. And so that's, in a nutshell, why genetic diversity is so helpful. Okay, I do want to acknowledge there are some super chats that come through. These all go to Buck Creek, the Friends of Buck Creek Watershed. It's a nonprofit organization that advocates for Buck Creek. Last year, there was a ton, and it got out of control, and we had to kind of put a limit on it. But this is Suleiman here, who's a fellow APES teacher. He is very generous to donate to Buck Creek, and also just an awesome APES teacher himself. So his students at Hampton Charter, I'm sure, are super well prepared for this exam because they have a super dedicated teacher. We've met at the reading in Cincinnati. So like I said, the reading is super fun to do, grading exams. So if you have a teacher who loves APES, tell them to go to the exam reading in Cincinnati. So thanks for that donation, Solomon. Like I said, that's going to the Buck Creek, Friends of Buck Creek Watershed. And you'll actually see, if you check out the channel later, we're going to go to Buck Creek with our class and do some cleanup. So you guys will actually get to see where any super thanks or super chat donations end up going to Buck Creek. So it's a really neat process. Again, I don't want to try to disrupt too much here. I'm going to see if I can save the super chats. Yeah, the super chats actually go in a separate section, which is really easy for me to put on screen. So we'll give Miss Kohler's APES class the shout out here. So your classmate Zaria is confident in you guys, thinks you got it. But again, I don't want this process, which is cool because it donates money to Buck Creek, to interrupt the live stream too much. So I'm going to just save those anything that comes through in a super chat for the breaks. Yeah, back to an FRQ example here. Okay, so actually let's go back because we skipped through ecosystem resilience. So another important vocab phrase to think about This is not like the most critical concept from a vocab term standpoint in the course, but it can be helpful when you're talking about biodiversity, which is resilience. Kind of basically the ability to return to your original conditions after there's some sort of disruption. And so an ecosystem with a whole bunch of species, again, if there's a drought that kills off 10% of the tree species, but you have a bunch more tree species that are drought tolerant, they're going to more quickly repopulate that decimated forest area, and you're going to have food sources for squirrels, you're going to have nesting sources for birds, you're going to have a food source for any, herbivore like a deer that eats the leaves of the tree maybe. So you just have a more stable ecosystem when you have a wide variety of species that can survive the disturbance. So that's kind of the why behind it. Great. Let's take a quick look at an FRQ example. Explain how species richness of an ecosystem influences its response to environmental stressors. So see if you can answer this. And we're like a hair behind schedule. So we're going to try to pick up a little speed in Unit 2, finish Unit 2 off quickly, because 3, 4, and 5 are where we want to spend a little more time. But I'm curious if we have anybody here thinks they can pick this point up. This is a tough point to earn. Let's take a look at this one from Tala. Oh, I wonder if this is Tala from GRP. If it is, shout out to Tala. She's an APES student of mine. Phenomenal scholar. She's been working hard all year. It might not be. It might be any old Tala. Anyway, species richness increases the reliance against environmental stressors within a population. Individuals with a certain set of genomes, or genes, I guess, are more likely resistant to disturbance to survive. Yeah, we're on the right track here. I don't know that this is going to earn a point. This is a really hard point to earn. An ecosystem with greater species diversity is more resilient because some species will survive and help to stabilize the ecosystem. So this is the part we're missing from this answer. Let's see how this answer does. Higher genetic diversity, which can make the population respond better. Again, we have this word respond better, but what we're looking for is the stabilization or the restoration of the ecosystem. So that's really what's missing. Ooh, high species richness increases the total amount of organisms within a species, which increases the stability of the ecosystem as they will be less susceptible to environmental stressors. I'm not actually seeing an answer yet that I think would earn this point. And that's also a good reminder, although we have way too many answers for me here to go through every single one. But this is also a good reminder of what we sometimes call a unicorn point, or a very difficult to earn point. So there's always going to be a point or two in an FRQ that's really hard and that I would skip and save for last, because you're more likely to earn other points that are easier. And so an explain FRQ is a great example of that. So I didn't see one right off the bat. This one, although the answer's been up on the screen for a while now, but this one is a little closer. Richness influences higher species resilience because they're going to be more of the portion of species who can survive and then restore the ecosystem from the environmental stressor. Yeah, this one's closer. And again, it's kind of a rephrasing of what's on the screen. But the thing to focus on here is that having a really high diversity of species can help stabilize a food web or an ecosystem by repopulating the ecosystem. Okay, we got to keep moving here. Ecosystem services. I'm not going to spend a ton of time on the different categories, but I want you to remember what an ecosystem service is, because a lot of times students forget and they think they're just things ecosystems do, but they're things ecosystems do that are goods or services provided for us. So humans benefit like explicitly and specifically from ecosystem services. So the provisioning services are really easy to remember. They're things we just like get right out of nature, lumber, paper, things like that. You've got the regulating and supporting, which students always mix up. I wouldn't worry that much about trying to keep them straight, but regulating, think of things as like stabilizing the climate, stabilizing air quality so that we then benefit from that. And then supporting is more like the direct support of something we already do. They allow ecosystems to kind of support us in our activity. So bees pollinating, if they're pollinating agricultural crop can be an example of that. filtering water so that we don't have to do as much water filtration ourselves. And then you've got the cultural ecosystem services, recreation, tourism, education, research, things like that. So let's try another FRQ example quick. Describe one impact the introduction of Asian carp could have on the ecosystem services provided by the Great Lakes. I like this question because Michigan, my home state, is one of four, or is it the only state? I think it's the only state that has 4 Great Lakes around it. And so we have a ton of Great Lakes access. And this is a question, the Asian carp issue, that's very, very relevant to Michigan. And remember, we have to target ecosystem services. I'm seeing a lot of answers in the chat that aren't. Oh, now this one might be Aishi again. Nice. This one might work. Asian carp are invasive species which may outcompete native species, thus harming the provisioning service, causing harm to fisheries and the economy. That should work. Decrease fishing due to carp outcompeting native fish. Yeah, you'd get this third bullet point here. So Aishi gave a great answer. And what Aishi did differently than some other students in the chat is Aishi's answer was aimed at the prompt, right? Aishi made sure to explicitly say which ecosystem service, fishing, was damaged. And so this is really, really good. Nice answer, Aishi. Okay. Keystone species. This is just a screenshot of an old exam FRQ to show you how a keystone species is defined. So beavers are a great example of a keystone species, but a keystone species is one that's so impactful on its ecosystem that like reducing that species number can drive ecosystem collapse or extreme instability. Another one is just they have a huge impact on their ecosystem beyond their relative abundance. So meaning only a couple small beavers in an area can have a huge impact on the area by building a dam, right? They can be considered what's called an ecosystem engineer. They knock down some trees, they build their dam. We now have a pond, what can become quite a large pond, where there used to be a little river or a little stream. That's a totally different ecosystem. Standing water versus running water is a very different ecosystem that can support maybe more amphibians, could be drinking water for organisms. It can even change how fire moves through the Western US. When you have these big beaver ponds, they can act as a fire break. So beavers, as a keystone species, have this huge impact on the landscape. Okay, must-know concepts. You got them here on the screen. I'm not going to spend too much time on them. We want to get to units 3, 4, and 5 because that's 10 to 15% of the exam each. Most likely FRQ topics. Ecosystem services show up over and over and over again on the FRQ, usually 1 or 2 points. So not a huge topic, but something likely to come up. Keystone species, also a very FRQ-worthy topic. I could see a whole FRQ based on like preserving biodiversity in an area, some keystone species that were removed that destabilize the ecosystem and why. That would be a very FRQ-worthy topic. And then biodiversity as a whole, it's just so likely to come up as a possible answer to an FRQ question. You know, a consequence of a human action often would be loss of biodiversity in the area because of, and then you say whatever the because is, or a benefit of conserving land could be increased biodiversity in the area. So biodiversity very likely to be on the FRQ section. Again, like can almost guarantee at least 1 or 2 of those 30 points on FRQ are going to relate to biodiversity in some way. Very confident that that'll be the case. Okay, let's do a couple teacher shout outs that came in the super chats. Let's do one more very brief recommended album. I won't give a review. It's an APES exam review, not a music blog. I get it. And then we'll move on to unit 3. Okay, we have Ethan Perez. You are so cool. You will pass the exam from Mark is Marketing. Wonderful. You also have a donation to Buck Creek in your name, Ethan. So if you watch the videos that go on the channel after the exam, make sure to watch for the cleanup in Buck Creek. All right. We have Miss Basilica of St. Mary's in the Key West and Mr. Wright, the best APES teacher in Florida. That's a strong statement. I know a lot of APES teachers in Florida, and there's some great ones. I don't think I've met Mr. Wright at the readings, but I'm sure he is a phenomenal APES teacher for you. All right. Oh, yeah. Let's see. We have one more here. Student says that their teacher, Mrs. Wages, got us held captive in the STEM timer. So are you actually watching the live stream from school together? That's kind of fun, actually. That sounds like a good time in the STEM center. Shout out to Miss Carso's class, especially the freshmen who got this. Yeah, if you have freshmen taking this class, especially want to make sure you work on those writing skills. Freshmen, especially who haven't taken an AP exam before, Miss Carso's class, I would consider looking at released FRQs from 2021 to 2024. That could be a really big benefit for the freshmen. All right. Mr. Wright is a popular shout out tonight. So Mr. Wright, well done. Your scholars appreciate you. They want to donate money to the Buck Creek Watershed cleanup right behind Grand River Prep, our school I teach at in Michigan, and they're very appreciative of you. So thank you for that. All right. We'll be going on to the next unit here. We'll try to catch some more. You know what? We'll do one more. A first-time APES teacher, Mr. Hedgka. I'm not sure if I pronounced that right. Hedgka. First-time teaching APES is tough. So the fact that your scholars are here, they're reviewing 2 nights before, and you're steering them in the right direction. So well done. It's a tough class to just jump in and start teaching. Okay, we will do our best to get some more APES teacher shout-outs in the breaks at units 3, 4, and 5. So there's still time. Recommended album here, Bon Iver, super, super peaceful music. One of my favorite Bon Iver albums. I'm a huge fan of Bon Iver. So I highly recommend check this album out. Throw it on in your post-studying relaxation. It's a real fun one. Okay. Unit 3. So K selected and R selected. This keeps popping up on the exam. It's also a super easy question to write MCQ test questions about. And so it pops up on the MCQ portion as well. I have to imagine. It definitely appears on practice exams. So we've got K strategists and we've got R strategists. K strategists, I always tell my students, they care for their students. They're the quality over quantity, right? They're going to have few offspring. They're not going to reach sexual maturity super quick. They're going to take a long time to develop relatively, but parents are going to take care of them and invest energy in them. They are more likely to be kind of disturbed by environmental change or invasives. But if they reach a large population size, they typically can kind of exist at that carrying capacity, which is why we call them K strategists. So they actually do well in ecosystems that are stable, like an old growth forest that's not really undergoing succession. So K strategists do have an advantage in those ecosystems. On the other hand, we have the R strategists who reproduce really rapidly. I always tell my students R for either rapid reproduction or R for runaway is the way to remember it. So they have their offspring and then they go. And that's kind of it. They don't invest much care in their offspring. They reproduce many times throughout their lifetime, often, not always. Sometimes they reproduce once with a huge amount of offspring, but often they're reproducing many times in their life. We've got insects, fish, and plants, all great examples. They are more favored in ecosystems that are kind of rapidly changing because they can really quickly reproduce a bunch of organisms, and then some of those will survive, even though many of them die, right? So this is going to be type 3 survivorship, big drop off in mortality, and then some will make it to old age, versus the type 1 survivorship. You have kind of high survivorship early in life, and then survivorship drops off late in life. So your type 1 and type 3 kind of go with K and R selected. Okay, some math. This is one of the only math like formulas you have to know for the exam. So the growth rate of a country as a percent can be found by taking the crude birth rate and the crude death rate, subtracting CBR minus CDR, and then dividing by 10. And the reason we divide by 10 is because the crude birth rate and death rate's out of 1,000, and we want it out of 100, percent per 100. And so we divide by 10 there. So an example, a CBR of 2 and a CDR of 8, subtract them, divided by 10, that means a 1.2% growth rate. Now, what the exam will often do is pair this with the rule of 70, which is 70 divided by the growth rate equals the doubling time. So there's almost always some kind of doubling time question. Again, on all the released exams in the past, MCQ exams that have been released, practice exams have this. It often pops up as an MCQ. And it did pop up as an FRQ 2 years ago. So it will appear from time to time. If you're nervous about the math, there's a math review video down in the video description. So you go, right down below this video, just scroll down and you'll see this math review video that will cover CBR minus CDR. It'll cover doubling time. And then if you're really nervous, you can also store equations in your calculator. And there's a video about how to do that. That's also in my link tree. So you can do this. You don't have to memorize that. Okay. We're going to keep it moving here. So if you want to try your doubling time math here, you can try this one. This is a tough one because you have to read really carefully. Give this one a shot, and you have to read really, really carefully. I think someone got it. So 70 divided by the growth rate is 37.2 years. And this student, Crumbs, they noticed that the question didn't ask for the doubling time in years. The question asked for the year the population of Charlotte will double. So this student figured out the doubling time, 37.2 years, and they added it to 2019, and they threw in current era on there. Just to be clear, we're not talking about 2019 BC. I assume that's what CE stands for, right? Current era. We used to say AD, but I haven't taken a history class in quite some time. So there is our answer, 2056. Again, the reason I want to highlight this is the APES exam questions will often be, they'll require you to read carefully. Like students might breeze through this and then just get the answer of 37 years and call it good. But you want to make sure you actually get to that correct solution, which is adding 37 years to 2019. So read these questions slowly. I can't say that enough. Read the questions slowly. Great question, or great work, Crumbs. All right, TFR. TFR shows up on FRQs from time to time. It hasn't shown up for a few years. Again, they don't rotate topics magically, but you would assume by law of averages, eventually we'd see some more TFR on the FRQ section. So total fertility rate, just average number of children that a woman's going to have in her lifetime. But we want to know factors that increase it. So high birth rate is going to be, high population growth rate. And the reason for that is often less educational opportunities for women, children being valuable in agricultural labor regions, it being just more culturally accepted to have a really large family in less economically developed countries. And then when countries get really wealthy, we typically see TFR drop, and we're going to go through those reasons on the next slide. The other vocab term that goes with this that a lot of students forget is replacement level fertility. And that just means if we wanted a population to just stay totally stable, so not really grow or shrink, how many children would need to be born? And in a highly developed country with really quality healthcare access, you're going to see that number about 2.1 because, one child to replace the mother or the woman, one child to replace the father, the man in this case, and you're going to then, have two people replaced by two people. But the reason it's 0.1 is that not every person, in a society reproduces. And so you're going to have some people that don't, and 2.1 is the rounding error basically. Okay. Let's see here. Someone caught the banner. Thank you. We are in Unit 3. We've been in Unit 3 for a bit. All right. A great question here. 2.5 in developing countries, right? There's no magic rule of exactly what number it's going to be in a developing country, but it's going to be higher. And that's what's important. So Anya here is pointing this out, that in a developing country, you're going to have a higher TFR, and that's because of infant mortality. So you might have to have, as a family, 2.5 children on average. I know you can't have 2.5 kids. You might have to have 2.5 kids on average for 2 to survive, right? So the other reason that replacement level fertility goes higher is because not every child makes it to adulthood and actually replaces the parents. So it's really sad, but a lot of children die in their first year. So the infant mortality rate of a developing nation will be higher, which means the replacement level fertility is higher. You need more total children born to still grow the population. Okay, let's see what else we got. Unit 3. We're going to round it out with the theory of demographic transition. And what we have here is something that may be familiar from AP Human Geo. So if you took AP Human Geo, you may have seen this. They have 5 stages. We just have 4 in APES. So remember, in stage 1, we don't really have stage 1 countries in the world anymore, but you have super high birth rate, super high death rate, so you really don't grow your population. If we go to the bottom of the screen and we look at the population pyramid here, really wide base, and then it's going to shrink in quickly. You're going to get a dramatic pyramid shape. And the reason for that is there's some die-off. I mean, there's some individuals that aren't making it to the next age cohort that are in the 0 to 4, but don't make it to the 5 to 9. But also just those people in the reproductive age cohort, they are having a large number of children. So that base, that 0 to 4, is just really wide because there's just so many babies born per person that's in the middle of the diagram. And by middle of the diagram, I mean reproductive ages, 15 to 40, demographically speaking. Okay, when we go to stage 2, this is where population explodes. So birth rate stays high because of cultural reasons, because of lack of access to contraceptions, lack of female participation in the workforce, although that starts to change a little in stage 2. The death rate plummets because of increased access to healthcare and clean water. Those are kind of the big ones. So way few people are dying early in life, and that means population grows because way more people are being born than dying. We still have a pyramid shape as our age structure diagram if we look at the bottom of the screen there, but it's not quite as flared out. It's not going to be as dramatic at the base as a stage 1 country. Then we go to stage 3, and the population is still growing, but the rate of growth is slower. So in stage 3, we have birth rate coming down because of access to contraception, things like condoms and IUDs and birth control. You have women's education is improving, so women just have better understanding of their own reproductive system, of how to avoid unwanted or unplanned pregnancy. And so those factors, it turns out, when women have control and knowledge and access to resources, they tend to have fewer children. Not because they don't want any children, but because they just decide when that will be for them and their family. And so that's family planning access is going to lower the birth rate quite a bit. But it's not all just the family planning aspect. There are just economic reasons too. People may be pursuing education and career opportunities later into life. They're not as likely to have children at 18 or 19 or 20 as they were, 50 or 60 years ago, even in America, because culture changes and economic forces change. So there's kind of an explanation of why that birth rate drops. The death rate continues to go down, but eventually we get to a point where you can't bring the death rate down to 0. People are always going to die when they reach old age, and you're always going to have some accidental death and death before old age. But the death rate comes very low. And then eventually in stage 4, the birth rate starts to approach the death rate. And as that gap between birth and growth rate narrows, that's when you get population that gets to almost leveling off. So it's very slow population growth. Potentially by the end of stage 4, you're at almost 0 growth, although you still have immigration often driving some growth. But that's kind of the process of this graph here. So those are some of the whys as well behind that change in TFR as you go throughout these phases, right? Total fertility rate. Okay. So let's take a look at must-know vocab terms, most likely FRQ topics. We'll try to do a couple teacher shout-outs. I want to actually highlight this on the screen here because let's say the FRQ was like, why is the TFR dropping in a country with a high GDP or an economic advanced country? This represents really clearly the reasons. Women are pursuing more educational and career interests or opportunities, so they delay their pregnancy or even not even getting pregnant at all. And so that delaying of pregnancy also just means you're going to have fewer children over your window of child reproducing age. So this is a great way to like explain in FRQ terms that TFR kind of phenomenon. Okay, let's just quickly touch on the most likely FRQ topics. R selected and K selected, it just keeps coming up on the FRQs in different ways. R strategists being more likely to be invasives, K strategists being more likely to be endangered. We had a protein insect question last year about why R selected would be, why these certain beetles would be a good protein insect source because they're R selected, they reproduce so rapidly. So this comes up on the exam. TFR is a topic that is likely to come up in the exam. You can ask a lot about it. It lends itself to data tables. It lends itself to questions both about human populations and about environmental impact of human populations. So TFR is a great topic. And then 3.9 pairs with kind of TFR. So I would expect if you saw a human population FRQ, you're going to see things like total fertility rate and the theory of demographic transition. Those phases talked about kind of in tandem, right? Because a country's economic growth and a country's population growth has environmental impacts. And so it's going to be woven into that FRQ in a way where you can get a lot of questions out of those topics. Okay, let's try to do the thank yous that have come in to people. All right, let's see here. We got a fellow Michigander. So shout out to Mrs. Dodson, the best APES teacher in Michigan. All right, go Michigan, go Mrs. Dodson. Awesome, your scholars appreciate you. Kay just wants to donate to the Buck Creek Watershed, Friends of Buck Creek. Or maybe Kay did this on accident. Maybe Kay only meant to make one donation. Shout out to Mrs. Michlovich from Steel Canyon. Very cool name, Mrs. Michlovich. Your scholars appreciate you, and they're feeling ready for the exam, it looks like. We have Mrs. Wager, the best Wager, I hope I'm saying that right. Best APES teacher ever. We're going to crush this test like invasive species crush native habitats. There we go. We love to see an APES pun make it into the teacher appreciation. We have Adam, who looks like a teacher himself. Thank you for everything you do to make students successful. Huge shout out to Mrs. Williams from Florida Virtual School. All right, so there's a Florida Virtual School here in the house. Wonderful. Shout out to Mrs. Piccolo and Miss Lau and Mr. Munn. Fun class. Tofu, great username. I love tofu. All right, let's see. Got Sanjaya. Shout out to McGeever and Narg. I'm not sure who Narg is, but shout out to McGeever, APES teacher, sounds like. This scholar wants to thank Miss Penwell and the freshman class of LEC. Awesome. Good luck, LEC. Again, if you're freshmen, I'd check out those FRQs on AP Central. It's a good way to get ready. We've got a shout out to Miss Mallory at ARGS. Miss Mallory, good job this year. Your scholars appreciate you. Oh boy, we got to go quick because we got content to review. Shout out to the glorious Mr. Rock. Roach? Rock? R-O-C-K sounds like Roach, but I would expect an A in there. Cowbad. Oh, where have I seen that before? Cowbad. That's definitely an acronym. So nice job with the acronym. Somebody comment Cowbad, the acronym, in the chat. We got an APES teacher from Massachusetts, Mr. Hone. And finally, Sally B, students on NC. Ahoyt. Yeah, I'm not sure what Ahoyt is. Oh, a shout out, probably just a misspelling. Okay. So a lot of teacher appreciation there. Again, can't get every single one, but sometimes if I catch one, I'll try to put it on screen here. We got great Redmond and Nickel from Washington. Your students appreciate you. We'll do one or two more here quickly for free. Miss Beckman, your students appreciate you as well. and Mrs. Gibson from California. I'm not sure what GERTYO is. I'm guessing these are acronyms. And we'll do one more because this student gave their teacher an award. Mrs. Roberts from Camas High School. Such a nice teacher. Almost everyone in my class is a freshman. I'm wondering if this is Camas, Oregon. There's a great novel set in Camas, Oregon. Anyway, shout out to the freshman there. Good luck. Okay, I know we did a lot of shout outs there, and you guys are here to review content. We do want to get to stuff. Album recommendation, Maggie Rogers. Been listening to this one a ton this year. Saw her in Cincinnati last year after grading exams. This is kind of how I wrapped up the exam grading, so super fun. If you have never listened to Maggie Rogers, very nice, peaceful music to relax with. All right. I'm going to go to Unit 4. We really got to hustle because at 9:30, I have to switch over to the Ultimate Review Packet stream. So probably what's going to happen is we're going to make it through Unit 4, do a good job with it, and I'm going to push Unit 5 to tomorrow. And so we'll go a little bit quicker. We can do Unit 5, 6, 7, 8, and 9 tomorrow. So we'll go through 4, and then we'll move on. Okay. Weathering versus erosion. Students definitely make this mistake of equating the two. So weathering is the breakdown of rocks into smaller pieces. This is how we get phosphate out of rocks. And then erosion is that movement of those sediments from one location to another. So we have the wind and the rain that kind of pick up the sediments and transport them. Very likely that erosion will come up on your test. Almost positive. It's right up there with biodiversity, like soil erosion. You're likely to see it, okay? Important thing to understand. So let's talk about soil. Soil has a whole bunch of different characteristics that we have to understand. So there's permeability, the easiness or the ability of water to permeate or kind of make it through the soil. I try to do the hand motions to try to help you visualize like water kind of coming through the pore space in the soil. So if you look down on the bottom right-hand side of the screen, we have a diagram there to kind of help you visualize. When you have big, large, connected pores in your soil, like a sandy soil, large pores and pores that are well connected, the water is going to drain through really easily. So remember, permeability, how fast does water drain through? Pore space, larger pores, are going to help that water drain through fast. Sand has big pores, so the water drains through it fast. Silt has much smaller pores, so the water drains through it more slowly. Clay has very small pores, and its pores are not always well connected. So soil that has a lot of clay does not drain very fast. On the other hand, we have holding capacity for water, which is kind of the opposite of permeability. How much is the soil retaining water, right? So again, more permeable, less ability to hold water. This is important for plant growth, right? A soil that's too sandy, the water just drains right through. A soil that's too much clay, the water sits in there and it gets waterlogged and it drowns the roots. They don't get oxygen because they're just sitting in water. You want a nice mixture, right? You want some sand, some clay. So a loam is a really nice mixture that has some sand, some silt, some clay. So the water can drain, but the water can be held enough by the soil that it doesn't also just like wash all the nutrients out with the water. It's another important subtlety of soil is that the nutrients can be leached out with the water. So you don't want the water to drain too fast because if it does, it can pull nutrients out with it too. And so you want to hold water, but not so much that the roots drown. So you want this kind of Goldilocks level of permeability and water holding capacity. All right, soil can be degraded, which is not a good thing. You can lose your soil. So if you're tilling too much or you're monocropping, you can have the soil losing its structure and the wind can then blow it away. And that's going to really reduce how much agriculture you can do in a region. You're going to lose the nutrients that were in the topsoil. And you're not going to be as productive with your growing. It can also be compacted though. So if you have cattle that are, grazing, overgrazing area, they can really compact the soil. You can have the machines that are engaged in farming. Those can roll over the soil and really compress it and really pack it down. And so both of these things can compact the soil so less water can get in. It's more dry, and it's also more likely to blow away in the wind. So this is a real problem if you're a farmer. You don't want your soil compacted and not holding water. Nutrient depletion can happen as well. So even if your soil isn't like totally eroded, if you grow the same crops over and over and over again, especially really nitrogen demanding crops like corn, you start to lose those key nutrients in the soil. Now in Unit 5, in tomorrow's live stream, we're going to talk a lot about rotational crop rotation. We're going to talk about intercropping and soil fertility. So we'll pair some of today's problems with some of tomorrow's solutions. I threw this slide in here just quickly because there are questions about atmosphere on tests, and I've definitely seen more kind of atmosphere related questions on practice tests as I've been working with my students. And so it's very well something that can come up on the exam. You want to know that nitrogen is the most abundant gas in the atmosphere. And again, that can help with nitrogen cycle questions as well, because the atmosphere is the biggest reservoir of nitrogen. Oxygen then is our next most abundant gas. And then you have these kind of trace gases. You've got a little bit of argon. You've got water vapor, which changes how much its percent makes up in the atmosphere based on temperature, based on the pressure and the conditions of the atmosphere in the area. And then CO2. It's kind of interesting. CO2 is a tiny percent of the atmosphere, but because it's so good at trapping greenhouse gases, because it is a greenhouse gas and it's so good at trapping heat, it plays a major role in climate change. And of course, we'll wrap up tomorrow's live stream by talking about that. Also just wanted, to briefly show the characteristics of the layers of the atmosphere here, because again, these are very like trivial concepts, meaning they're usually not major focal points of FRQs, but if they come up on the FRQ, they're going to be very simple. Do you know this or don't you know this questions? Usually. It's not likely you're going to have this complicated application question about layers of the atmosphere. The big ones to focus on are troposphere and stratosphere. So I always try to remind my students that tropo, that suffix or that prefix tropo means change. And the troposphere is always changing. It's where the weather is always changing, right? So weather occurs down on the troposphere, the lowest layer of Earth's atmosphere. And then the stratosphere, I always tell my students S for second, but also S for saves. And so in the stratosphere, we have that ozone layer that saves us from the sun. So there's some word associations that can help you try to remember the difference between these two. All right, this is a slide that's really helpful on FRQs if you have an environmental problem and solution pairing. So very quickly, I want to go through these solutions to watershed pollutants. So these are ways that human land use, this really kind of goes more in Unit 5, but because Unit 4 has watersheds, we'll cover it here. But these are ways that human actions or land use can pollute watersheds and then solutions to it. So if we look at A, cover crops. In a cover crop, you're going to plant something after you harvest the main crop so that your field isn't just bare. So instead of having nutrient and sediment runoff right into this stream or river, the cover crops take up some of the nutrients and they keep it there, but they also anchor the soil. And then when you're done, you can mow your cover crops under or chop your cover crops down and green manure or fill them into the soil. And not only are those nutrients kind of pulled up from the soil and then redelivered to the topsoil, but a lot of the soil is held in place by the root structure of the cover crops. Cover crops are a huge environmental solution to erosion and to nutrient loss in soil. They also keep the bodies of water cleaner. Then we're going to go out of order just because I'm going clockwise around the graphic here. Animal manure management. So we want to have manure lagoons that are well lined with a plastic liner. They get pumped out frequently. We can even take them out and we can spin off the liquid and we can use those, the biomass that's left, the feces of the cows, we can use those to make fertilizer pellets. So we can get a product out of manure management and we can decrease the chances that the CAFO manure lagoon overflows and runs into the body of water, right? That's going to pollute it with nutrients, with E. coli. It might pollute it with growth hormones that are in the cow to, cause them to grow faster. All of those are things we don't want in our water. Let's go to solution B. Solution B is an awesome one, which is building a riparian buffer. Again, I keep talking about Buck Creek because my students are going to Buck Creek after our exam to do a bunch of stream cleanup. We're going to do some water quality testing as well. Buck Creek has decent riparian buffers, but it could be better. A riparian buffer is basically your vegetation along the stream. And that can catch and absorb nutrients or sediments that are running off a body of land into a body of water and improve the quality of the body of water because of that, because they've trapped those sediments, their roots have taken some of the nutrients in, and they're not flowing into the body of water now. If we look at nutrient removal, enhanced nutrient removal, this is tertiary treatment. This is a wastewater treatment technique where you filter out nitrogen and phosphorus extra beyond just what happens in secondary treatment when the microbes break down all the organic matter. So this is something a wastewater treatment plant could install. We call it tertiary treatment, and it takes out even more nitrogen and phosphorus before the treated effluent or wastewater treatment, result is dumped back into the river. Then we have septic tank upgrades. Those kind of go with the nutrient removal. So if you have a septic tank, it can just be pumped out sooner. You can have a drain field that's deeper and is going to be a little better at filtering pollutants before they, reach the groundwater, before they overflow. And then if we look at E, they don't have a name on E, but E is kind of going to be like a retention basin or a way to have like bioswales or rain gardens. So your urban runoff, that stuff from the road that has salt, if you're in Michigan, that has oil on most roads, it has trash, litter, sediments, that's going to be, going over into a retention pond that's going to like hold the water and slowly filter it with plants' roots. Could be rain gardens that do the same thing. Permeable pavements, another option to try to reduce that amount of runoff. But these are all solutions to problems of runoff carrying pollutants into bodies of water. Oh, here we go. What a topic to end on. Oh gosh, I've just noticed this one too. All right, tomorrow I'm going to need to have a designated banner changer because I always forget that one. I'll put myself a reminder in the slides tomorrow, so it'll be a little cleaner of a presentation. This is always the dress rehearsal. Night one is the warm up. We work out the kinks in the live stream. So I'm sorry to the people that are bothered by the wrong banner. Okay. Let's throw this up on the screen just for a second because it's a good question. So, actually, I'm sorry. I thought they said tertiary and secondary treatment. So tertiary and chemical treatment, chemical treatment, I wouldn't use that on an FRQ because it's too vague. I wouldn't use chemical anything on an FRQ really. Chemical, everything's a chemical, right? So tertiary treatment specific though, you don't have to know the ins and outs of it, but it's an advanced filter system that's going to be able to grab onto some of the nitrogen and phosphorus as it passes through. Kind of similar to a dry scrubber or a wet scrubber when we're talking about the air effluent that comes out of, or I guess you wouldn't call it effluent, but the exhaust stream that comes out of a waste stream, in a power plant. It's kind of like that, but it's just pulling these nutrients out of the water before they're returned to a river or stream. Okay. Final topic of the night, El Nino and La Nina. This one's a doozy, okay? So what I always try to remind my students is you have to know a couple things about a normal condition, the normal condition in between El Nino and La Nina. And if you can do that, then you can learn El Nino and La Nina. So normally, and first we have to know where we're talking about. So we're talking about the equatorial Pacific. And the name El Nino, little boy, and La Nina, little girl, can also help you remember what they are and where they are. So El Nino was first kind of discovered or documented by Spanish-speaking fishermen off the coast of South America, okay? Off the west coast of South America, or in the eastern side of this diagram, equatorial Pacific. So off the coast of South America, the fishermen noticed, kind of around Christmas time, that the fish populations were much more scarce. They weren't catching as many fish. The water got a little warmer. The weather got a little rainier in that region. You had low pressure systems. You had sometimes even flooding in that region and depressed fish catching, right? It was lower hauls when they brought up their nets. And because it happened around Christmas time, which is the arrival of a little boy, baby Jesus, they named this kind of condition El Nino. And so if you remember, it's called El Nino, you can remember El Nino means little boy. So we're talking about a Spanish-speaking region, and that can kind of remind us we're over there on the coast of South America, Chilean fishermen especially. And then the way I teach my students to remember, it's definitely a little bit sexist. It's just a mnemonic, so it's not an actual statement about gender, but little boys tend to be more hot-tempered or feisty than little girls. Not all the time, but little boys play fight more. They can be a little angrier. And so I always tell my students, just remember, little boy reminds you of the Spanish-speaking fishermen in off the coast of Chile. And then also little boys are, think red being like kind of a hotter, angrier color, and think red or think hot temperatures. Because what happens in El Nino is you get the reversal or weakening of the trade wind. So instead of blowing the warm ocean water from east to west, like happens in a normal year, and you can see in that diagram, we get the surface water kind of pooling up all this warm water off the coast of South America. And so it's concentrated over to the east in this diagram because the winds are weaker. That shuts off the upwelling, which is that cold, nutrient-rich water that comes up from the deep ocean and brings oxygen and nutrients and supports really productive fishing. So in an El Nino year, we have worse fishing off the coast of South America and in this Pacific region because the warm water sits on the surface and it prevents the cold water from mixing up and replacing the warm water. However, in a La Nina year, I always tell my students, remember, La Nina is larger than normal conditions. So the wind is back to blowing east to west. We get those trade winds along equatorial Pacific, along the equator. And so now the water's extra cold and the fishing is extra good off the coast of South America because that wind is being blown, or that wind is blowing the warm surface water over to the western side of the diagram. So it's over in Australia, Southeast Asia. And the effects that follow go with the air temperature. So what you just have to remember is warm air rises. As it rises, it cools and it can't hold as much moisture. So the water condenses and falls as rain. So you have low pressure systems, you have warm weather, you have extra rainfall, so increased risk of flooding. You might have increased risk of crop loss from the storms. And so just remember, if you can remember the direction the wind blows in a normal year, and then you can remember it reverses or weakens in a El Nino year, you can remember why that warm ocean water kind of pools up and why it brings all those weather conditions and kind of shuts off the productive upwelling that used to support the fisheries. So that's El Nino, La Nina. I'm going to go back for one question here because this is a very valid question. I don't understand the pressure part. Can you explain that? Yes. So warm air rises. That's just a basic kind of physics fact that we have to try to remember. It's because it's less dense. Right? When things get cold, their particles kind of slow their movement down. They move closer to that solid state of more dense particles than in a gas state. And so, when something's hot, its particles are moving around faster, it becomes less dense. And since it's less dense, it will be above something that's more dense. So it will rise. So warm air rises. And again, the air is warm because of that warm ocean water. And so that's what happens. The warm ocean water that's blown over by the trade winds, in a normal year to Southeast Asia and Australia, that warm water gives rise to warm air. Warm air rises. Now, when it rises, it has less pressure on it because there's less atmosphere pushing down on it. And so when it expands, air cools because it's now under less pressure. It's called adiabatic cooling. You don't need to know that for the exam, but you do want to remember that as air rises, it expands, and that expansion is going to cool it. It's going to be under less pressure, and so it's going to have lower temperature. Just think of climbing a mountain. When you climb a mountain, the air gets really cold, and then it can't hold as much moisture because it's colder, and so it rains. And that's kind of how we get a low pressure system leading to warmth or coming from a warm system, and then raining and having potentially floods or loss of crops. So that's often how it will appear on the exam. If you're really confused about El Nino, La Nina, you can watch the 4.9 video. It's not usually a huge FRQ concept, but it could come up, could be something you want to review. So that is El Nino and La Nina. Okay. Just a little summary here again of like how might you see it pop up in the exam. The reason I have it in bold for suppressed upwelling is because they often connect El Nino and La Nina to the human outcomes or the economic outcomes, right? The suppressed upwelling, the less productive fisheries. You have all these knock-on effects here. These aren't as critical to remember. The ones I always focus on are the increased risk of flooding in South America when we're talking about, the increased risk of drought and less productive crops as well when we're talking about an El Nino year in South America. We're talking about a La Nina year. We're actually talking about better fishing conditions because of how much cold, nutrient-rich water is coming up to the surface and supporting all these fisheries. That's, again, really where we typically see questions make the El Nino, La Nina connection to human outcomes, right? Fishing outcomes. Okay. Let's go on here to our must-know vocab terms. I have 4.3 as a most likely FRQ topic because it comes up over and over and over again on FRQs. Unit 5 also comes up a lot, which involves soil. Soil can appear in a bunch of ways on the exam. It can appear as sediment in runoff. It can appear in graphs where we're talking about soil erosion. It can appear in an experiment where we're talking about runoff and turbidity. It can appear in one of your answers to a question about like effects of urbanization. We could have sediment runoff. Soil is just such a versatile topic that's so likely to come up on the exam. So again, if you're trying to pick between concepts to study tonight or tomorrow, soil is a very relevant concept on the exam. Like it's just going to show up on both the MCQ and FRQ section in some way, most likely. Is it possible you have 30 questions and soil's not in any of them on the MCQ or FRQ? It's possible. It's not likely. It's really likely that soil in some way, shape, or form will be a possible FRQ answer or explicitly on the FRQ. So I would study soil. Watersheds and their pollutants and solutions, those also appear on FRQs year after year after year. And then I have El Nino and La Nina just because it's complex, and so you can pull a lot of questions out of it, right? It's ripe for an FRQ. There hasn't been one about it forever, but again, exam readers, it's not like they keep a list of, or writers, it's not like they keep a list of which topics they have to hit, but they are humans who write questions every year. So eventually it could come up. But it has a lot of nuance and a lot of complexity to it. And so that's why it could be an FRQ topic. I wouldn't freak out about it. I wouldn't spend hours trying to master El Nino and La Nina tonight or tomorrow. I would maybe review like a few minutes of that video if you're really worried about it, but I'd focus more on soil and watershed pollutants and solutions. Okay. Let's wrap up with any shout outs that came through that I didn't hit. And then we'll see if there's any last minute questions. And then I need a little bit of a break. So the Ultimate Review Packet live stream will start more like 9:45 because I'm running out of voice here. I need to take a little breather. And I still need to go, teach my students tomorrow. So I need to have some voice left. Okay. We're going to start off here with it's Dolphin Man. Shout out to Mr. Young, the best, sassiest APES teacher in New York. All right, Mr. Young, so you got a sass to you apparently that your scholars seem to appreciate. It probably keeps them in line. All right, here we have another shout out to Miss Grabhorn and all the freshman STEM scholars at McIntosh High School. Good luck to you guys. A lot of freshmen taking APES. Again, if you're a freshman taking APES, I'd especially recommend FRQs tonight. Look at some FRQs on AP Central. We have Miss Mitchell at Santa Paula High School in California. A sustainable queen of Mitchellland. Okay. We love a sustainable queen here. Love to hear that. That is wonderful. All right. Oh boy, a self-studier. We have a shout out to Maddie and Sloan who self-studied and they had no APES teacher. Self-studying is hard. Good luck, especially if you're self-studying. I would check out some FRQs. So Sloan and Maddie, search APES FRQs, go to AP Central. and answer some of those sample FRQs. You really got to try sample FRQs if you're a self-study student. Extra important. Oh, I love this. We have someone who's shouting out their study group. A study group's a great thing to do. I'm going to, in my video next year about like how to do well in APES at the beginning of the year, I'm going to recommend a study group. We have Socrates in your study group, Noelle, Maddie, Annabelle, Lily, and Alice. Sam loves you all and is manifesting 5 for all of you. All right, remember with the manifestation, you know, you do still have to do some studying. You do have to still write like a scholar. You can't just manifest it. If you want to manifest along with the writing like a scholar, go for it. But make sure to do some studying too, not just manifesting. Although who knows, maybe we should run an experiment. So some of you don't manifest, but study for an hour. And then some of you manifest and study for an hour. And we'll see if the manifesting, you know, increases the average test score. That'd be a fun experiment to do. All right. We have a shout out to the APES freshman teachers from AB, again, Hone, maybe, H-O-N, the GOAT, H-O-H-N, the GOAT. And then one final shout out here. Thank you to my APES teachers, Miss Lau and Miss Piccolo. I think we had a couple of shout outs to them earlier. So awesome work, APES teachers. We'll do just a couple more. I know this is fun for you guys to thank your teachers. Also, let me try to answer a couple more questions that are also relevant. So we'll do this one real quick. Miss Aldred, again, all freshman classes. I'm really impressed by the teachers that take all freshmen and get them ready for an APES exam. This is a good question. A quick cram review summary video before this year's exam for some concepts, topics. Yeah, I am actually going to do one last live stream where I really try to hit like maybe just 3 or 4 topics that I think are most likely to be FRQs. And I'll do that actually the morning of. So I'll get the live stream scheduled and put it up. But because it's a noon exam, I'll probably aim for like 9 to 10 Eastern, something like that, at a time when a lot of you are probably actually in school with your teachers. So if you want to tune in and check out some last minute like run-throughs of topics that are likely to be on the exam, I'll actually do one day of as well. But there'll be one more tonight. And then also, of course, shout out Mrs. Henderson from SWFL. Not sure where that is, but shout out to Miss Henderson. Okay. Units 5 through 9 is tomorrow. Yes, very good question. We're going to have to go a little quicker tomorrow. I'll be quicker. There won't be as much intro. I won't really do any intro tomorrow. I'll just tell people the one slide of like, what should you study weighting wise. So we'll get in quicker tomorrow. All right. That just about does it for units 1 through 5. I think I had one more reminder here. Fred again, great album. A lot of fun to listen to if you're biking. I like to bike into school sometimes, so you could check that one out. Yeah, give it a shot. Okay, Kyra is sending in some links here. Check out the link tree if you think you missed anything. Check out the video description. If you want to rewatch any of this, it will be in the live replay section of the YouTube kind of homepage, you know, within, I don't know, 20 to 30 minutes. So if you got in late, you can check that out. All right. So yeah, tomorrow is units 5 through 9. We were going to do 1 through 5 tonight, but I ran out of time and I have to go to the Ultimate Review Packet live stream. So again, if you have the Ultimate Review Packet, pop over to the Ultimate Review Packet and you'll see the live stream is going to be right at the top of that left-hand panel there. All right. So we are going to move on here. Oh, we had one final thing here. This is a callback to way earlier. You're right. Camas is in Washington. So there's a book called The Brothers K, not the Brothers Karamazov, The Brothers K. And some of that takes place in Camas, Washington. It's a really beautiful book. So if you like reading novels, check that one out. It's a beautiful part of the country. I love the Pacific Northwest. So you live in a really pretty part of the country. All right. I think that is how we'll wrap that one up. I guess 1 or 2 quick questions that are still relevant here. Yeah, if your teacher wants to give you some practice questions, you can ask them tomorrow. Like you can say, it's not too late. Can you give me some practice MCQ and FRQ students? And in fact, if you're a Grand River student of mine, you got some great FRQs to practice tonight still, although it's getting close to bedtime, so you should probably go to bed soon. But you can write some practice ones tomorrow still. Math and experimental design. Highly recommend it. Okay, this is, I think, where we need to wrap up. And what I'm going to do is end this live stream. And then, if you're in the Ultimate Review packet, you can go over to that exclusive live stream review. And that'll be a much slower pace. It'll be a lot less people. And we'll mostly be doing Q&A. So I won't be going through a bunch of concepts that I've planned out. I'll be answering your questions and pulling up whatever slides are going to be like helpful or relevant for that. So as always, think like a mountain, write like a scholar. Good luck in your studying. And I'll see you here tomorrow night at the same time, 8 to 9:30 p.m. to study units 5 through 9, not 6 through 9. We'll add unit 5 in. So good luck. Get some sleep though. And yeah, think like mountains, write like scholars. You guys know the drill.